Hi, in this video, we're going to look at how to use the chain rule to differentiate composite functions. We'll work through 3 sets of examples, and you can download this PDF from my website if you want to work along with me. If we begin with question A, so we need to differentiate this using the chain rule. The chain rule allows us to simplify it. So if we let t equal the 3x plus 4, then we can rewrite this equation as y equals t to the power of 5. And we can easily differentiate this. This will be dy by dt. This will be 5t to the power of 4. The problem we have is that we want dy by dx, not dy by dt. But if we have dy by dt, we can multiply this by dt by dx. And then you can see that these dt's will cancel, and we're left with dy over dx. So we need to find dt by dx. Well, if t equals 3x plus 4, then dt by dx will just be 3. So now we can use dt by dx and dy by dt. So dy by dx will be with dy by dt, 5t to the power of 4, multiplied by dt by dx, which is 3. So a gradient function will be 5t, and remember that t is the 3x plus 4, raised to the power of 4 multiplied by 3. And we can tidy up this 3 and the 5. We can write this as multiplied by 15. So this will be dy by dx. So to use the chain rule with functions like this, we need to identify the inner function. This is what we let t equal, and the outer function. If we look at question B, what do you think we need to let t equal now? So we'll let t equal the x squared plus 1. And now we can write y in terms of t. This will be t to the power of 6. So dy by dt will be 6t to the power of 5. And if we want dy by dx, this will be dy by dt multiplied by dt by dx. And we can work out dt by dx. If we differentiate t, this will just be 2x. So dy by dx will be dy by dt, 6t to the 5. And we can write t back in terms of x using the x squared plus 1. We raise that to a power of 5. And then we multiply that by dt by dx, which is 2x. So dy by dx, we can tidy this up. We'll have the 6 times the 2. Then we'll have the x. And this is multiplied by x squared plus 1 to a power of 5. Okay? Do you want to try question C and D? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. Question C, we'll let the t equal this inner function. So t equals x squared plus 3x plus 4. Then dt by dx will be the 2x plus 3. And we can write y in terms of t. This will be the square root of t. But to differentiate this, we'll write it as a power. So dy by dt, we'll bring this power down. We'll get 1/2. And then we'll take away 1 from that power. So dy by dx will be dy by dt. I'm going to write this as a fraction. So 1/2 root t multiplied by dt by dx. Now we can tidy this up. So dy by dx will be 2x plus 3 over 2 root t. And remember that we let t equal this term here. So x squared plus 3x plus 4. Okay? For question D, now we need to let t equal this 2x plus 3. So dt by dx will just be 2. And y will become 1 over t squared. But because we want to differentiate this, I'm going to write it as a power. So we'll have t to the negative 2. So dy by dt will be negative 2 t to the negative 3. And I'm going to write this as a fraction. So we'll have negative 2 over t cubed. So dy by dx will be dy by dt multiplied by dt by dx. So we'll get negative 4 over 2x plus 3 cubed. Okay? Let's try example 2. So in example 2, we need to find the gradient of each of these curves at a given point. So if I work through question A, and then you can try question B. So when we differentiate sine cubed x, it's easier to write this as sine x all cubed. And then we can see that we need to let t equal the sine x. This is the inner function. So y will equal t to the power of 3. So dy by dt will be 3t squared. And we need to multiply this by the derivative of that inner function, dt by dx. And the derivative of the sine x is cos x. So dy by dx will be dy by dt, 3t squared. And I'm going to write t back in terms of x. So sine squared x multiplied by dt by dx cos x. And to work out the gradient at x equals pi over 3, we can use one of our special triangles. We've got the angle pi over 3. We know this is 2, this is 1, and this is root 3. So the sine of pi over 3 will be the opposite over the hypotenuse, root 3 over 2. And the cos of pi over 3 will be the adjacent over the hypotenuse, that'll be 1/2. So dy by dx will be the 3 multiplied by sine squared x, so root 3 over 2 squared, multiplied by cos x. So we'll have the 3, root 3 squared is 3. Then for our denominator, we'll have a 2 squared times the 2. So we'll have 9 over 8. So our gradient of sine cubed x at pi over 3 will be 9 over 8. Do you want to try question B? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So we need to let t equal the cos x. And then y becomes the natural log of t. And when you differentiate this, dy by dt will be 1 over t. And dt by dx will be negative sine x. So dy by dx will be dy by dt, 1 over t, which is cos x, multiplied by dt by dx, negative sine x. So we get dy by dx. And negative sine x over cos x is negative tan x. So at pi over 4, dy by dx will be the negative tan of that angle, which works out at negative 1. Let's try one more question. So do you want to read through question 3 yourself, and then try and find the equation of a tangent to this curve at the point 1.5? You can pause the video and come back when you're ready. Okay, so if we let t equal the x squared plus the 3x. Then dt by dx will be the 2x plus 3. So now y will be 1 over the square root of t. And I can write this as a power, and that'll be t to the negative 1/2. So dy by dt will be negative 1/2 times t to the power of 3 over 2. I'll write this as a fraction, so dy by dt will be negative 1 over 2 t to the 3 over 2. So I've written it as a fraction because I'm going to multiply it by dt by dx. So that would be our numerator. So dy by dx will be negative 1 over 2 lots of t, x squared plus the 3x to the power of 3 over 2. And this is multiplied by the dt by dx term. So we can tidy this up. Dy by dx will be negative 2x plus the 3 over that denominator. Now to work out the gradient when x equals 1, dy by dx will be negative 2 plus the 3, so negative 5. Then we'll have the 1 squared plus the 3, so 4. Raised to a power of 3 over 2 will give us 8. We'll double that and we'll get 16. So dy by dx will be negative 5 over 16. That's the gradient of a tangent when x equals 1. So using the equation of a straight line, we'll have m multiplied by x minus 1 will equal y minus 1/2. We'll expand that with negative 5 and we'll move the 16 over to the right hand side. So negative 5x plus the 5 will be 16y minus 8. We'll move a negative 8 to the left hand side and we'll divide both sides by the 16. So this will give us the equation of a tangent to a curve when x equals 1. Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.